In May 2025, engineers from the Naval Research Laboratory journeyed to 29 Palms, California to test their state-of-the-art RASP-CASA system with unmanned aircraft systems, or UAS, and hydrogen-powered technologies in an effort to bring long-range capabilities to today's warfighter.
RASP-CASA stands for Refueling and Servicing Package, Communications, and Situational Awareness. We're bringing together a bunch of different technologies to provide a new capability to the warfighter. So the goal is to demonstrate the value of hydrogen in several different use cases. One of which is high-altitude balloons. Another is long-range endurance hydrogen fuel cell-powered unmanned aircraft. And the third is low-signature electrical production on the ground.
So during this demonstration, we were able to demonstrate all of the automated launch equipment technology and the use of hydrogen to develop and enable the over-the-horizon communications to the UAS. We use the balloon to enable that communication relay link between the operator ground station and the UAS. And with that, we can provide full motion video and command and control to the operator through the balloon.
So typically, a Group 2 UAS like the Stalker unmanned aircraft that we used here can fly about 50 miles out to the horizon and maintain a line of sight communications link. Using the RASP-CASA technology with this high altitude balloon relaying the signals, we can now fly an airplane like that well over the horizon and really expand the range over which warfighters, Marines, and sailors have situational awareness.
Fuel cell technology has come a long way from the 1980s into the current present time. We have been able to figure out how to manufacture these capabilities and these devices here in the United States, which is an enormous improvement over where we were at 10, 15 years ago.
I think it's important to emphasize that while hydrogen is often discussed in an environmental context, it does provide clear warfighting benefits that otherwise wouldn't exist. So we've demonstrated two of those here today. And another one that I should mention is the fact that hydrogen can be produced locally, which is unique and offers some real logistics advantages to the warfighter. At this demo, we're demonstrating the capability-focused portions of the RASP-CASA program. So the high-altitude balloons, the long-range endurance unmanned aircraft. There's another piece of the RASP-CASA program, which is a hydrogen production system intended to go shipboard. So long-term, over the next 10 years, what we'd really like to see is a series of demonstrations that use that hydrogen production system aboard a ship to launch high-altitude balloons in unmanned aircraft and demonstrate how these technologies can be employed in operational context by the Navy.